Andy Moore. I work in the marketing team at RISC-V, and I'm here to introduce the lightning round. So we can all tell our story mostly within 15 minutes, but can we tell it in 2? This is a stern test of messaging and professionalism. So each of our talkers are going to get 2 minutes, and they've got a countdown here. When their 2 minutes are up, I will give them a signal, and if they don't finish quickly, then we can all clap them off stage politely. So this should be fun. So first up, we've got Larry from Synopsys.
Okay, so Olympics are coming up. This is the sprint here. Let's go. So Synopsys. Wow, 90% of advanced chips use Synopsys technology. This is pretty amazing. Synopsys is a big company. Most everybody is aware of Synopsys, so this is a really good start. And now Synopsys is doing things in RISC-V. So what do we have on the RISC-V side? Optimizing QOR and productivity. There are a whole bunch of tools available here, including, I will specifically point out the MPSoC solution for RISC-V processor verification. The next panel, our early architecture exploration and software development. There are a number of tools available here. There's a group actually that builds a tool called ASIP Designer that's really good on the architecture exploration side of things. And also we have these flexible RISC-V virtual prototypes and the hardware-software partitioning tools. Great stuff. Moving down, accelerating software development, virtual prototypes, and then the hardware emulation, FPGA prototyping tools. And then finally, Synopsys actually has a full solution for RISC-V, including RISC-V IP, but also including the other IP that you need for your SoC. The final slide says we've got a poster up today. There's a poster up tomorrow. I'm giving a longer talk on Thursday talking about the processor models, and hopefully you'll come and listen to that talk. We're Synopsys. We're really working hard on RISC-V here. Come to the booth. Come and hear the talks. Thank you very much.
Hello everyone. I'm Vince Wu from Andis. So Andis is a 19-year-old public company, and we are actively in the open source RISC-V communities. And so far, Andis has announced 30 different RISC-V cores from entry level up to auto-folder, high performance level. And last year, it's our first time to reach 1 billion revenue in Taiwan dollars, setting up an office here in Munich. Our customer shipping volume is over 14 billion pieces. And this year, we will keep announcing more RISC-V cores in auto-folder, automotive, as well as in another core in the vector series. So all of our RISC-V cores can run in together with our AI Accelerator i350. And as you can see here, in the IP market report by SHD Group, it reveals Andis has taken over 30% RISC-V market shares. So if you are having an Android phone, highly possible inside the Wi-Fi and Bluetooth chip, there's an Andis core inside. If you have home appliance, face recognition, voice recognition devices, highly possible Andis RISC-V inside. If you are surfing Facebook, Instagram every day, recommendation system, Andis RISC-V inside doing the computation. So our RISC-V is also in the space, storage, enterprise SSD, gaming SSD, 5G network devices. So Andis is driving the innovation with RISC-V. And our customer is driving innovation, putting our RISC-V inside, driving on the ground in automotive by different applications like touch monitors, cameras, in-cabin radars, CMOS sensors. So if you are interested in RISC-V latest technology, we have a booth out there at number 8. We have different posters at group ABC. And this RISC-V everywhere in our life. I'm Vince Wu. Thank you very much.
Not bad. 3 seconds over. Not bad. So next we have Alessandra Dolmeta from CEA.
I'm Alessandra from CEA from Grenoble, and today I will present you one of our latest work about a new kind of integration for Accelerator in RISC-V. Everyone knows that with the rapid advancement of embedded system, we need to have the special purpose accelerator in order to boost the performances when running specific application. And one crucial aspect of this kind of integration is the degree of connectivity between the core and the accelerator. What we have exploited in this work is an emerging interface of RISC-V, which is the Core V extension interface. That is a new interface that allows the seamless integration of a tightly coupled accelerator without any modification to the core and without any modification to the toolchain. It ensures extremely low latency because it is directly connected to the register file of the core, and you can add custom instruction by simply using a use of code of the core. Now, we have tried this new interface with a post-quantum cryptographic algorithm, which is Crystal Kyber, and being an algorithm that should be resistant against a quantum computer attack, it is performing EV computational function that should be accelerated with custom instruction. In our case, we use a butterfly accelerator that is performing the central operation on the polynomial multiplication of the numeric theoretic transform function. And what we have obtained by adding two different kinds of instruction, the R type and the R4 type, has been a reduction of 3 times the number of clock cycle and instruction by simply adding a single instruction and by simply adding an accelerator with these interfaces. So if you're interested about more implementation detail, you can come visit me on Thursday at the poster section and also at the booth of CA. Thank you.
Thank you.
Good afternoon. First of all, I want to say ESWIN is not Synopsys. So I'm sure most of you does not know ESWIN. So today I want to share with you who is ESWIN. So ESWIN is a platform-based fabless company. Our core technology is RISC-V, as you can see. And we have 1,800 people worldwide, developed IC and the solutions across the 4 scenarios, from panels to smart devices, to industrial and automotive. Here is our main product. Our products on the panel level, we developed for TV, NB, monitor, cell phone, automobiles, the drivers that we call panel drivers, TCONs, and touch, as well as PMIX. In addition, we provide all the ICs behind these panels, such as TV SoC, monitor scalers, smart monitor SoC, Wi-Fi 6, MCUs, PMIX, building the total solution for our customers. In addition, we provide AI PC and edge computing ICs, along with the platform solutions for education, for industrial use cases. Today, I'm very pleased to launch our 77 series. The IC use case across all 3 use cases. One is edge computing. Secondly is AI PC. Third is accelerations, because I have 2 minutes. So for more product information, please visit our booth. And I'm looking forward to work with you to provide more product based on RISC-V. Thank you.
Thank you. Excellent work.
So Frontgrade Gaisler is a European hardware component, IP core and software vendor. We primarily service the space industry, and this picture shows some of the places in the solar system where our products are being used. Near Earth, you can see the Novel 5 logo, and that is our in-house developed RISC-V processor model that has achieved flight heritage within an FPGA. But that's not the only thing that we do to bring RISC-V into space applications. What you can see here is the functional diagram of our next generation product that we're going to launch. So this is a fault-tolerant, radiation-hardened SoC that we will manufacture on ST Microelectronics. And we are developing this in collaboration with the European Space Agency, with support from national space agencies in Europe. And what this is the 5th generation European space-grade microprocessor. So it's an octa-core RISC-V implementation with our Noel 5. So all or most of the building blocks that you see in this architecture are also available as separate IP cores to license from us. And we have a booth here today, and I would love to talk to you about this one, about IP cores and RISC-V in general, so please come and stop by our booth. Thank you.
Hello. Hello together. So we are from Lauterbach. We are all about debug and trace tools. And this means enabling embedded innovation has always been at our heart since our establishment more than 40 years ago. And today we are talking about enabling embedded innovations with RISC-V. Now, what does that mean? Well, we have to start early. We have to start with standardization, and that's happened already some time ago, making sure that debug and trace standards are there and are working, and we have achieved that with trace standards being now almost ratified and solid. Yeah? Debug standards are already available. Yeah? And then next typically comes when SoC design, people come to us and ask us what do they have to take care about, thinking about debug and trace infrastructure. This is where we help them in the first place. And later then when we talk about verification and validation, of course, when our tools are then used to verify and validate the corresponding SoC designs to take out the risks before first silicon arrives. Biggest part, of course, for us is bring up and software debug. RISC-V will live often with other cores, other architectures together. This is where we can help. How can you actually work with such system? How do you debug that? How to trace that? This is like what we can do and where we can help. And finally then, when we move from prototypes to final products, we can help you with debugging and tracing over interfaces like USB and XCP. So enabling innovation with RISC-V is all about us today. If you have questions, if you need help, come to our booth. We have interesting stuff there, and we have our experts here at the show today. Thank you.
Thank you, Andy. Good afternoon, everyone. I have two things that I'm going to talk to you today about. The first is our 4th generation. Oh, no, that's not the right slide. That's the correct slide. So the first thing is our 4th generation of our essential products that we announced this morning and that are available today. If you're not familiar with our essential products, these are our foundation CPUs. They're a range of 32-bit and 64-bit real-time and Linux-capable cores. They've been really, really successful. They've been widely deployed. We have over 350 design wins. We have over 2 billion chips have shipped using these essential products. And as you can see in the timeline, these are products that we've been working on for a decade, since Krista and the other founders of RISC-V first started working on these CPUs. And we've released several generations, and the 4th generation that we've released today has various improvements that have been driven by our customers. We've obviously increased performance, we've reduced power, we've added a whole load of additional features, security features and other features that we've added. But one of the important things about the essential products is the way that customers can configure them in many, many different ways. And so we've added further enhancements in terms of how those products can be configured to enable our customers to build even better SoCs. And the second thing I wanted to talk about is the HIFive Premier P550 development board. We obviously don't just do embedded processors, we do high-performance processors as well. And this product includes one of our out-of-order cores, the P550. Come and see it on our booth. We have a demo running of that. I guess the one other thing to say about this, you just heard from Bo at ESWIN. This is a product that we are bringing to market in partnership with ESWIN, and that's a partnership we're really excited about. And this is the first of several boards that are going to be coming over the next couple of months. So watch this space. But in the meantime, yeah, come see us at the booth to talk either about the P550 or about our essential Gen 4s. Thank you.
Thank you, John. Next up, we have Klaus Strohmayer from Tristan project.
Good. Okay, so it's about using SmartWave for RISC-V-based device emulation there. As semify, we are part of the Tristan project, a European-funded project which targets to enhance, mature, and industrialize a RISC-V-based ecosystem there. And as every funding project, it's organized in work packages. We have the 3 work packages, core work packages on processor families, hardware peripheral implementation, and software implementation. They are surrounded by the work package 1, which are the requirements, all supported by the work package 5, which are the EDA tooling, and also to see some outputs on work package 6, which are the demonstrators. Everything is held together by the project management and dissemination work package. Our contribution within this EU-funded project is mainly on work package 2 and on the demonstrator work package 6, where we are working on instruction set extensions for open hardware core CV3240X and doing their instruction set extensions for decompressing and compressing digital waveforms. Where do we use this? So we use this in our product SmartWave, which provides for the user a dedicated RISC-V core in order to implement target device emulation for the user. There we implement our instruction set extensions to compress and decompress digital waveforms, but also provide the possibility to extend it to further other dedicated application-specific use cases there. If you want to know more about Tristan itself, or want to know more about semify or engineering service and SmartWave, then visit us at the Tristan booth over there. Thank you.
Hello, everyone. So TeraPines is a company which provides a single platform for software and hardware co-design and co-optimization. So we are going to address these problems and opportunities. So the highly specified compute, AI inference, network, and DSP create enormous opportunity for DSA. So doing DSA right is key for RISC-V to succeed. Having DSA optimize the software tool chain is necessary and is time-consuming, costly. So we are going to provide a solution to tackle these problems. So from left to right, we provide 3 solutions. The first one is AI tool chain. So currently, we are developing a data flow AI tool chain for all RISC-V-based AI processor, which is under development. And the middle one is this solution, which is a complete RISC-V IDE with high performance compilers. The compilers will go through ISO 262 certificate before the end of this year, and is ready for evaluation and for delivery. The last one is a co-design and a co-optimization tool, which is the Explorer, which provides a virtual platform to modeling the microarchitecture and to customize the instruction, all without real hardware. So as a compilers focused company, so we have collaborated our IP partners such as Andes, Nuclear, and other IP providers, and we highly optimize our compilers for further IPs. I'm not going to the detail of this data. You can come to our booth and to try our online tours and to talk about this tour chains. Thank you.
Hi, so I'm going to give you an introduction to the test and embedded analytics from Siemens EDA. So it's a portfolio of IP components that you can integrate into SoCs. The objective is to provide a real-time functional monitoring environment. So it provides IP functions such as transaction-aware bus monitoring,
logic analyzer functions, static instrumentation, trace encoders, and runtime control and monitoring, cross-triggering. It has an integrated infrastructure for connecting all the components together, which has a cross-triggering capability built in from the ground up. And so the benefits of this solution really are it's primarily aimed at optimizing your system software and system bring up. It's, in most cases, first time you get to run your real application code is when you actually get chips back. And then you need to find out why they're not running as fast as they should, or why they're using too much power, and so on. So it's aimed at accelerating your in-lab system bring up and shortening time to market. The same IP can also be used once the product is deployed to collect information which can be used as part of an integrated silicon lifecycle management solution. And there are software toolkits available as well to help with the development of the analytics software, either for embedded or for host-based. And I mentioned trace on the previous slide, and I just wanted to go into that in a little bit more detail. So the trace encoder we have supports the efficient trace for RISC-V standard, which was actually developed originally by UltraSoC Technologies that Siemens acquired, and then was donated to the RISC-V International. And it is fully compliant with both instruction and data trace capabilities of that standard. Also offers a cycle accurate extension, which is above and beyond that. So if you're interested, would like to know anything more about the technology, please come by our booth. We'll be more than happy to talk to you about it. Thank you.
Well, everybody was very well behaved. I'm sorry you didn't get to clap anybody off the stage this time round, but next time maybe. So yeah, thank you to all the presenters. Please give them a big round of applause. Thank you.